so we are here to see if we can get flex fuel to work. So if you watch previous video we were able to get speed density to work. I had mentioned at the end of the last video for that, that the only way we're going to do flex fuel is if we used ECU because we needed intake air temp in order to make it work. I was wrong. I've done more research. Not only is there no intake air temp compensation adjustment tables on ECU there's no reference map for it either, so I don't even know what it does. So we know a reduction in intake air temperatures will give us more ignition timing, and we're going to figure out how much. That's part of what we're going to do today. And we also know that if we increase our MAF voltage, it will increase the pulse width of our injectors and increase the amount of fuel that we get. So I have made this. Now, it looks like a hot mess because I just tossed this together as a proof of concept. Now, I was already out here this morning with another car trying this, and it wouldn't work for some reason. So I went and I looked, and it was because I had this DAC on the wrong 2 pins. Excuse me. But I went back up into my office and I got this working. So what this does is we hook up our flex fuel sensor into, I have a program for pin 3. We hook up our mass airflow voltage into pin 0. And then through some math that I have created, we change the mass airflow output to the ECU, which is this pin with the butt connector on it. This voltage will change what the input voltage is to whatever I want it to make the mass airflow think that it's getting either more or less airflow. And by doing that, we can artificially raise the mass airflow reading up, which will increase the amount of fuel that the car is getting. So I know that it works, as in I get an output value from here. I know that it works that I get an input value from here, and I know that it works that I get an input value from here. So now we just need to test that it works and test that it does what I think it's going to do. Now, I don't want to hook up the flex fuel sensor to this car and go through all of the plumbing and everything to make that happen, because this is just a test. So what we are going to do is I have a really long lead here to a flex fuel sensor. I have a can of E73 is what that is. So what we're going to do is we're going to hook all this up, make sure that the voltage to the mass airflow sensor at 0 ethanol, 0 to 15% ethanol, which is gasoline, comes into here and goes out at the same voltage. Once we confirm that, I will then hook up the flex fuel sensor into this, and I'm going to take a little bucket and fill it with some of that fuel, and I'm going to just dip that in there so that just the lower part of it is seeing that, so that it gets an ethanol reading. And we're gonna see if the car starts to run really, really rich. I'm gonna wanna see that air-fuel ratio get really, really rich and see the compensation try to compensate for it. Now, it shouldn't compensate for it too much. I'll get into all of that. So that's kind of where we're at. We're gonna make sure that changes. And then the plan is, I have a second one of these. It's called a DAC, digital to analog converter. I gotta set up a second one of these that's going to interrupt our intake air temperature or charge air temperature so that we can manipulate that, and that's where we're gonna get our increase in ignition timing from. Now this is gonna be super finicky at first until I figure out how everything works. But the plan is we'll get the math working, make sure that does what I want, we'll disconnect it, and we'll just hook it back up to this, to the air temperature, and I'm gonna just change the inputs and outputs on the air temperature to see if I can watch the ignition timing rise. Based off of how most factory vehicles are set up, we should be able to get 4 to 5 degrees of ignition timing by just making this air get colder and colder and colder and colder, by tricking it into that. And again, it will still have the safeties of, as the actual air gets hotter, it's gonna push that value up a little bit, so it will pull a little bit of the timing out as it's supposed to. So we're not on the dyno for this, just like when we did the initial tests for speed density. So we're gonna go ahead and we're going to just test this stationary, rev it, make sure everything works, and then we're gonna go from there. I have 2 more wires I have to put in here because I did put a feedback system in here to monitor the output voltage and confirm that output voltage matches what we're requesting. If not, it will adjust the DAC in order to get that voltage to where it's supposed to be so that it's exactly accurate, which is extremely important for the mass airflow since it's going to be changing so fast. So, enough talking, and let's see if this works. Okay, so we're all hooked up. It's essentially the same kind of deal as with the map sensor thing that we did, except this time we actually want the mass airflow voltage, which is this. Again, this isn't pretty, this is testing. We've got a huge length of wire so that our unit is away from the car, so it doesn't vibrate away, but we're all hooked up. So we have teeing off here for our feedback loop to verify the voltage. That we have this being powered by the 5-volt sensor power system, which is able to put out a couple milliamps, which Arduinos for this particular application don't draw a ton of amperage, especially since we're not putting out a ton of amperage. DACs are not designed to be a power supply for something. They are strictly for reference, so that'll work. Again, flex fuel sensor is not hooked up because I want to just make sure that we get a 1-to-1 output of voltage to this to make sure that it still operates normally when the flex fuel sensor is not hooked up. Then we'll introduce the flex fuel sensor, put some ethanol through, and see what it does. So our ignition is on. We have power here, so the power supply system is working. I'm going to plug in OBD scan tool now and check our voltages. And then I'm going to plug this into a laptop so I can monitor what our voltage in and out is supposed to be and see if they correlate. I could be, super lazy and just put a multimeter on these and see if they match, but it is what it is. So I'm going to turn the ECU back off now that we know that powers that, and check and get everything set up so that we can start checking stuff. Okay, so we have a mass airflow voltage of 0.5 volt, which I believe that's what they are when they're off. So I'm gonna fire the car up and we're gonna see if that continues to work. Okay, let's see what happens. Well, that's good. See what happens when the RPMs come down, if that drops down. I'll let it warm up for a second, then I'll start recording again when I start testing it. All right, so the RPMs just dropped down from the cap warm-up cycle, and you can see that the math voltage drop. We're gonna snap it. Oh yeah, we are in business. All right, so we know that works. So we know we're getting an output from that is correct for the vehicle. It didn't go into limp mode or anything. So that verifies that we are getting a 1-to-1 in and out. So now the next step is to hook up the flex fuel system to this and see if it really screws with that reading. So with the ignition on, we got 0.5 volt. When I hook the flex fuel up, we should see a different voltage for a reading just sitting still. It's gonna kind of confirm whether this is working or not. So I'm gonna go and hook up the flex fuel sensor. I'm gonna pour out a little bit of ethanol fuel so that I can dip the sensor into it to get it to read. Again, I don't wanna hook this up yet. I wanna verify everything's working before I do that because it's not easy to do that hookup on here because you got to run a lot of lines and stuff because the nylon tube that they use doesn't move, so stuff's got to snake around. So I'm gonna get all that set up and we'll see where we're at. Okay, so we have data logging on, we have our ECU, whatever, I don't know what to call it yet, and we have our flex fuel sensor sitting in some ethanol. So right now MAF voltage is around 0.5 volts with the engine off. I'm going to plug in our flex fuel here. Let's see if that value changes at all. Okay, so we have no change in that value. So let me get the Arduino plugged in so I can monitor the serial port to make sure that we actually have an ethanol content reading. Been at this for about 2 hours since the last clip, and I can't get the ethanol content sensor to read, and I tried a second ethanol content sensor, and that still won't read. I've tried a couple of different codes. I even did just a unit for just ethanol content to see if maybe there was a interference in the code. Doesn't seem to be wanting to work though. I tried changing to common grounds and I can't get a reading out of it. And what's weird is I'm not getting a frequency out of it when it's not even hooked in. Again, I tried 2 different ethanol sensors, and this has a oscilloscope built into it, and it's not getting anything out of there. Trying to figure that out. 4 hours later, we got this figured out. So I needed a 10K pull-up resistor to a 5-volt source, and now we're getting frequency. And I just dipped it in some fuel, and the voltage in the hertz went up. So now I got to rewire everything so that I can try this again. So we have our ethanol content all the way on the left, 0. I'm gonna put the sensor in the fuel, and it's climbing right to 74-ish%, which is how much is in here. I'm gonna take it out. It takes a second because this fuel is sitting in it, but it goes back down to 0. Okay, so that works as it should. So now we look at our MAF in and our MAF out values. When I increase our ethanol content, our MAF out value should change. And it did. And then it should go back. All right, so this is working. So now what we're gonna do is we're gonna fire up the car, and then we're gonna dip that into the ethanol with the data logger on, and we should see the car start running like crap, to be blunt. That's kind of what we're hoping to do here. So there's a kind of a process I have to do this in, because I need this to get its power from the car. So I have to unplug this to turn the car on, and then I can plug it in so we can watch the serial monitor. Actually, we really don't need to watch the serial monitor because we know it's working. Okay, so we're just gonna unplug that, fire the car up, and then watch data logs. All right, we're data logging. We're gonna dip it. Here's my MAF voltage so I can read it. MAF tank 1 voltage is that one. Oh yeah, the car's running like caca. Now we take it out, and then we go back. All right, excellent. I'm gonna let it warm up so the O2 sensors work, and then we're gonna do that again. All right, so we have air fuel ratio is working, and then our compensation or correction amount. So when I dip this in, we'll watch the corrections. See, it's pulling fuel. It's trying to pull fuel. Fantastic. All right, let me shut this car off. If we look at our map traces here, which is what you'd basically be tuning off of, you can see every time I would dip into the ethanol, we would move up volumetric flow ratio by a good amount into this area, which is why it started to run really rich. And then over here, our base fuel schedule would go over and kind of freak out a little bit, which would move our timing over to here. So, and then it would level out because the base fuel schedule uses other stuff. So, that works. Sweet. Okay, now for the harder part, we need to put the MAF back the way it was and then get into our charge air temp, which is on the map sensor here. And we're gonna see how far back we have to pull our voltage before we start seeing the compensation add ignition timing. So add ignition timing to this list, play around with my compensation values so that it adjusts to a colder temperature, and see if we can get it to just add timing sitting here at an idle. I'm not sure if it will compensate at an idle, but we're gonna We're gonna find out. All right, so the higher our voltage, the colder it is. So we're going to make it so that when temperatures, when the ethanol count increases, our voltage increases as well. So let's do that. Okay, so we have the map sensor tapped into. There's butt connectors everywhere. This actually used to be somebody else's car that had one of my stainless steel intake manifolds on it, which they transferred onto their new car. So that's why there's weird wiring going on there. So we're going to fire it up, let it warm up a bit, dip it into the ethanol, and then as we do that, we're going to watch our data log and watch our ignition timing and watch our charge air timing. Our charge air temperatures, and make sure everything changes the way we expect it to. I have it so that when it's dipped in there, it should be decreasing the temperature by like 35%, which is a pretty substantial change. So let's see if it works. All right, everything we're watching is pretty much over here. So I'm gonna dip it in and we'll see what happens. Dipped in and nothing's happening. Okay. So it didn't change the intake air temp, which means the charge temp sensor on the boost sensor, I think, is just monitor intercooler or charge pipe health. The intake air temp sensor 1 is here. So what I'm gonna do is we're gonna tap into that, put that back, tap into that, and see if that changes anything. So there's a code for these cars, P011C, which is a intake air temp correlation code, which when you put a bigger front mount on the car, it will throw that code because that doesn't match what it's supposed to compared to that temperature. This kind of confirms that it has a set range that it's looking for and that this is really just to check stuff. That's kind of what I'm getting to. So we're gonna do this sensor and see if that changes anything. If that doesn't change anything, then I'm gonna have to really dig into this because we might have to actually modify both signals to make them read colder. Because as you saw, when my ethanol content went up, my intake air temps didn't change at all. So I'm gonna move the wires over and we're gonna see what happens. Well, it doesn't like something I did because it says it's 380 degrees in there. Huh. Interesting. Okay. So it kind of makes sense. Temperature sensors are resistance-based sensors, so outputting a voltage isn't gonna change anything because it needs to see a change in resistance. We need to be able to get the timing to advance, or there's no reason for going flex fuel. I don't want to have people change to different maps depending on how much ethanol they have. That's ridiculous. That's not flex fuel. Even if the fuel automatically adjusts to get more timing out, I think that's just ridiculous. I think it should just automatically do it. I'm going to do a little bit of research and see what I can come up with for a solution for that. Just not entirely sure what I'm going to do for a solution to that. We'll see. Okay, so there's two ways I can do this. We can continue with this, which I'm not sure is going to give me the results I want, which would involve me doing a digital potentiometer of sorts, or we can do something that actually gives us two benefits in one. Now, I really like to retain OEM boost control, like really like to, because you get safeties and you get the automatic adjustments that come with it. And the way the ignition timing map works is based off of, I believe, fuel, Jesus, I do this for a living, you know, is based off of base fuel schedule, which is also your ignition timing. Now, an issue that, I'm just gonna say it, upper of cars had last year and the year before, is when you would data log them, it would stop recognizing the map sensor. So you would just have a ton of ignition timing and it blew up cars all over the country. At last count, it blew up 5 of them. That's not the moral of the story. The moral of the story is we can actually bring down our base fuel schedule by reducing the boost signal, which will also increase our boost by a certain amount. So let me show you. So if you're, I'm just gonna make up numbers here, so just play around with me. Say you're running 15 pounds of boost. That brings your base fuel schedule out to about here, right? Now, if you tell the car that you're only making 10 pounds of boost, it's actually gonna read off of this area, which, as you notice, the further you go that way, the higher your ignition timing, right? So, and you can fiddle with this. And obviously, if you make the sensor think that you're making less boost, it's gonna wanna get to its goal, so it's gonna increase your boost. So we can get a twofer out of this. We can increase our ignition timing and our boost, which is ethanol is great for. So that right there is gonna be a trick. And the good part about that is, unlike a temperature sensor, which is a resistance-based sensor, this is a raw analog voltage sensor. So I can take in an input, send out whatever I want, and we can change our base fuel schedule. So next time, I'm going to do that. I'm gonna have to do some research because I need to figure out how to get 2 of these working on one Arduino to do the testing for this. I think I know how to do it, but it requires soldering little itty bitty tiny things right there. So I'm gonna play around with that a little bit, but this is definitely going to work. We are gonna have flex fuel and speed density. Cool.